Okay, so we are continuing. This is a continuation of 2.7. 2.7, we are multiplying slash dividing. Although I guess if I move this down, you'll see that. We're solving one-step equations still, but now we are multiplying and dividing instead of just adding and subtracting. So the same rule applies, and we already wrote this down in our other set of notes, but whatever you do to one side of your equation, you have to do to the other. So we have to keep our equation balanced. And this is exactly what I wrote for your adding and subtracting notes. One more thing I want to add to this is we want to isolate our variable. So remember, with these, when I write, you're writing, or if it's something that's typed, I'll go ahead and highlight it for you if I want you to write it down. So remember, our title is Solving One-Step Equations Using Multiplying and Dividing. And then what I want you to be writing is you want to isolate the variable. And what this means is we want to get the variable. Now remember, variables just like X or Y or Z or A or B or C, the letter. Get the variable alone on one side. All right, so let's start with our first example. Okay, in our first example, we have 5y equals 35. So I want to get this variable alone. I want to isolate my y on this side of the equal sign. So how we're going to do that is we're going to undo the operation that we have going on this side. This means 5 times y equals 35. Well, what's the opposite of multiplication? It's division. So we're going to divide both sides. Remember, whatever I do to this side, I have to do to this side. We're going to divide both sides by whatever's connected to our variable because we want it to be alone. So we're going to divide this side by 5, and we're going to divide this side by 5. Well, 5 over 5 is equal to 1. So this just really means 1y, or y, is equal to 35 divided by 5. So that's going to be equal to a positive 7. All right, now the next one, example 2, we have x over 5 equals 7. Well, this time our original equation has division, right? This just means x divided by 5 is equal to 7. Well, up here, we kind of know the answer already, but how we're going to do this is we're going to, instead of dividing both sides by 5, we're undoing this division right here, and we're multiplying both sides by 5. Multiplying both sides by 5. So, and we could even say this is 5 over 1. So 5 times x over 1 times 5. That would just, again, give us 1. These two cancel out. This is going to give me x equals whatever 7 times 5 is, and that's 35. Now notice if we go back and check both of these, we're putting our 7 back in for our y. So this is 5 times 7. Does that equal 35? That's what we're checking. And yeah, it does. We know 5 times 7 is 35. So 35 equals 35, and we are happy. Now over here, we have our x over 5 equals 7. And we got down here that our x equals 35. So let's check this one. Does 35 divided by 5 equal 7? That's what we're checking. And yes, it does. We know 35 divided by 5 is 7. So 7 equals 7. Everything checks out. So these are our checks. I want to make sure I see that. So now I'm going to do a your turn. So go ahead and pause here. See if you can try these. Okay, so these should have been the answers you got. X equals 4 for A, M equals 4 for B, A equals 27 for C, and N equals 20 for D. Notice over here I've put all of our checks just in case you didn't know where I got those numbers from. So now we're going to try some special cases just like in the last notes. Okay, so example number 3, we have negative 72 equals 9a. So for negative 72 equals 9a, remember we want to get this variable a all by itself. So we want to undo whatever operation is going on between 9 and a by doing the opposite. Since this is multiplication, we want to divide both sides by that 9, making this our 1. So what would our answer be? Well, what's negative 72 divided by 9? Remember, a negative divided by a positive is going to give us a negative answer. We know it's negative 8, so negative 8 equals A. Now for the check, we got to watch our signs. We have a negative 72. Does that equal 9 times a negative 8? Well, yes, it does, because again, a positive times a negative is going to give us a negative. All right, example number 4. We have negative 15x equals negative 75. So notice how these special cases just have negatives in them now. So negative 15x equals a negative 75. Again, we want to isolate our x. We want to get this x alone. So let's undo this operation, which is multiplication. How do we undo it? We divide it by a negative 15. Watch the negative sign. Make sure you do add it. Since we divided this side by negative 15, we have to divide this side by negative 15. And what do we get? We know this equals 1. So what do we have left over here? We have our x. Now a negative divided by a negative is going to give us a positive answer. So 75 divided by 15 is going to give us a positive 5. Now if we go over here to our check portion, does negative 15 times 5 give us a negative 75? And it does, because again, a negative times a positive will give us that negative answer. Our next one, of course, we're going to do division in our original equation. So it says h divided by 6 equals negative 3. So we want to undo the operation going on between this h and 6. How do we do that? We times both sides by 6 or 6 over 1, whichever is easier for you. It's the same thing. So this becomes 1. We get h equals what's negative 3 times a positive 6. That's going to give us negative 18.